This is the makeup lesson for water cycle lesson 5. You've learned some facts about the water cycle already. We've learned that the water cycle has 3 main parts: evaporation, condensation, and precipitation. And you've learned some facts about the water cycle. Here's some facts about water and air that we learned before our Memorial Day weekend. We learned that hotter air can hold more water than colder air, that during the day, air is hotter than it is at night, that when air gets colder, condensation happens. And now I'm going to ask you a couple of questions based on these facts. So go ahead and pause here and reread these until you get it, and then move on. Okay. Which air can hold more water molecules? Hot air or cold air? When is air generally hotter? During the day or during the night? So the air picks up a lot of water during the day, and then that air cools overnight. Will the cooler air be able to hold as much water as it held when it was hotter? So what takes place? Condensation or precipitation? And if enough condensation takes place, the drops in the cloud get too big, and then we have precipitation. Let's move on to something new. This is a relative humidity chart. Let me explain. Air that is wet is humid. What word is used to describe wet air? The amount of water or moisture in the air is called relative humidity. What is it called? This chart shows the rules about relative humidity. If air is holding all the water it can hold, the relative humidity is as high as it can get. That's 100%. What's the relative humidity of air that has all the water it can hold? When the relative humidity is 100%, it's raining or snowing because some of the moisture in the air is coming out as precipitation. Remember, 100% humidity is the highest amount of water the air can hold. 0% relative humidity means that there are no water molecules in the air at all. The air is as dry as it can get. So for 0% relative humidity, it's the lowest possible relative humidity. It is the driest it can be. 50% relative humidity means that the air is holding half the amount of water it can hold. So that air is a lot wetter than 0%, but it's a lot drier than 0%. Than 100%. Let me repeat that. That air is a lot wetter than 0%, but it's a lot drier than 100%. 50% is half the water air can hold. Remember, the highest relative humidity is 100%, and that the air is very wet when it is closer to 100%, and that the air is drier when it is closer to 0%. The percent shows the relative humidity of air masses. What is the relative humidity of air mass A? What is the relative humidity of air mass B? What is the relative humidity of air mass C? Which of those air masses has the highest relative humidity? What's the relative humidity of that air mass? Which of those air masses has the lowest relative humidity? What's the relative humidity of that air mass? Which of the air masses has the driest air? Which of the air masses has the wettest air? Let's try it again with this set of air masses. What is the relative humidity of air mass B? What is the relative humidity of air mass A? Which of the air masses has the lowest relative humidity? Which of the air masses has the highest relative humidity? Which of the air masses has the driest air? Which of the air masses has the wettest air? Which of the air masses would be able to pick up the most amount of water before that air had 100% relative humidity? What's the highest relative humidity that air can have? The opposite of dry air is wet air. What word describes the state of wet air?